good morning to you all, and thank you again for joining us at the 7th Symposium of Rising Scholars. So glad you could join us all on this beautiful Saturday morning. My name is Alex Armstrong, and I am the Head of Product Design and Data here at Polygence. And today I'll be your moderator for this first session of the Computer Science and STEM series of projects. In this session, 5 students will share the work that they've been working tirelessly on for many months. And I'm incredibly excited to introduce you to them. So first we have Misha, Nivota, Shlok, Desai, Krishnaveni Parvataneni, Claire, Loftus, and Morchio. I'd also like to introduce you to our evaluator for this session, Rahul Patel, who will be watching all of the presentations and helping us nominate some of the students for awards and prizes at the end of the sessions. So each session will be between 5 and 8 minutes, after which you'll have the opportunity to ask questions of the presenters. So feel free to ask those questions during the presentation. We have a Q&A feature built into Zoom. And when you share those, I'll share them with the presentation with the presenter after the conclusion of their talk. So without further ado, let's kick it off with Misha and Nivota.
Okay, hello everyone. My name is Misha Nivota, and this is my project on analyzing the accuracy of neural decoding algorithms. So first, a quick intro into neural decoding. Neural decoding is using machine learning and AI analysis to analyze neural data. So the data you get for neural decoding typically has a stimuli, which is an event or some sort of thing that triggers a response in an organism. And the responding neural information, the neural information that coordinates that response would be your dependent variable in this data set. And so the goal of neural decoding is to determine what the stimuli is using the responding neural information. So for my project, I was first introduced to neurotechnology at school, where we learned about the Center for Neurotechnology at UW, where they were using machine learning to improve Parkinson's treatments. So I was really interested in the merge of computer science and neuroscience, and that's what I approached my mentor with, and he suggested doing a project in neural decoding. The project we designed had a very hands-on approach where I would use neural decoding algorithms myself, and it was the best way to learn and improve my machine learning knowledge. So my data set was from data recorded from a macaque monkey. It was given to me from my mentor from U Chicago. So the stimulus of this experiment was a directional cues given to the monkey, and the monkey would respond by moving a joystick in that specific direction. So the neural activity from the motor cortex that was correlating to that arm movement was the response. This data had 143 trials and 158 with data collected from 158 neurons. So there had been previous decoding algorithms used with this data, and the highest previous accuracy was 86%. But as I was learning about neural decoding, I found out that different algorithms work very differently, and some have their benefit and they do better with certain data sets than others. So I was trying to figure out if there was a better algorithm for this data that could yield a higher accuracy. So my next step was finding the right algorithm. I evaluated several different algorithms, such as maximum likelihood estimation, Kalman filtering, vector construction, but I ended up choosing support vector regression. So support vector regression builds on support vector machines, and the way it works is it classifies data into separate groups and classifications by using a hyperplane. If you look at the image to the side, you can see that there's a line, the hyperplane, that divides the red dots and the blue dots. The red and blue are different classifications. So the goal of SVR is to define that hyperplane that correctly splits the data of any classification. And once the hyperplane is defined, the support vector regression algorithm uses that hyperplane to classify unknown data points. If the data point resides above the hyperplane, then it's one classification. If it's below, it's another one. So the advantages of SVR is it's very insensitive to outliers, because if there's there's data points that are slightly off, it doesn't make as much of a difference in how the hyperplane is defined, and it doesn't really affect the model. It can also be used for many classifiers because you can have multiple hyperplanes and also multi-dimensional hyperplanes to look at more features. SVR also requires less computation than most algorithms and is much easier to implement. So finally, building the model. I used an existing SVR model on GitHub in a GitHub repository. Once I got the basic model working with the GitHub data, it was pretty easy, but now I had to figure out how to get my data to fit. The data for the existing model was very specifically formatted, and they actually described how it was formatted in the repository itself. So I had to structure my data very similarly. It's probably the most time-consuming section, but after I did that, it just had to be entered into the model and it was working. But even though the model was working, its original accuracy was very low, around 12%. If you remember, my goal is higher than 86%. So I had to make several small tweaks. First example, I changed how the data was divided for training, testing, and validation. There was a lot of trial and error where I would sort of change a number, run the entire model, see if it made any change in accuracy, and I just kept trying and trying. And after a lot of trial and error, I resulted in a much higher accuracy. So my results, my final R squared was 0.8247 or 82.47% accuracy. As you can see in the confusion matrix on the side, a lot of the issues lied with the 0th and 7th directions, because as you can see, there were 4 correct answers and 6 correct answers to that, respectively. That will come into play later. For my analysis, unfortunately, my model did not improve the accuracy of previous models. It was still lower than 86%. A couple possible issues was with my data set. The model template in GitHub had a data set with much more values. So it could be something wrong with that. And also there was less data from neurons tuned in certain directions. That could be why my model wasn't doing as well with 0th and 7th directions. Finally, there could be problems with the model itself because this SVR algorithm was not created for my data. If I made my own SVR model from scratch, built specifically to analyze my data, it might have yielded a much higher accuracy. But overall, my accuracy was still pretty good. It was 82%, which it's still pretty good. And to conclude, what I learned is I learned a lot about neural decoding, and I got to work a lot with the ML process, with the data pre-processing, actually getting the model to work, doing the tweaks to improve accuracy, and I just got to experience the whole process. And as for the applications of what my algorithm and also what neural decoding as a whole can do, is it's very useful in diagnoses because it can help you see the brain better, understand what it's doing, and therefore be able to diagnose it better. And it's also creating new pathways and advances in neuroscience, as it's a very different way of viewing the brain than before, and it's helping us understand it better than ever. These are my references. Thank you for listening.
Thank you so much. All right, so a reminder, so if you have questions you'd like to ask, go ahead and throw them into the Q&A tool at the bottom. I already see some floating in, so I'll start asking those, but feel free to ask whatever is on your mind. So first question, what was the most surprising part of this research?
The most surprising part was I actually didn't expect most of it to be spent on data pre-processing. I thought I'd have a much harder time with the model itself, but the model itself wasn't that difficult, and it was mostly iterating through the data and trying to figure out how to get it in the same form as the GitHub data. That was really challenging, and I wasn't expecting that.
I'll tell you, after working with data for my entire career, that is a good realization to have at this point in your life. One other question. If you or another student wanted to extend your research, what suggestions or recommendations would you share with them before they undertake that?
If I wanted to extend this research, I would definitely try and make a model from scratch, or at least learn how to, because I feel like that could have worked a lot better. But unfortunately, I don't think I had enough time to do that. So if I could extend it even further, I'd definitely start with trying to figure out how to build my own model.
Very good. All right. With that, thank you very much. Let's go ahead and move on to our next presenter, Shlok Desai.
Okay, let's get started. Hello, my project is called Diagnosing Major Depressive Disorder using activity data from wearable sensors and machine learning. It was made by myself and my mentor, Brianna Marsh. So here's a quick table of contents before we start so you can see what is upcoming. So about me. My name is Shlok. I'm a senior at Doherty Valley High School. I'm a prospective computer scientist, and I'm passionate about making a change in the world through technology. Onto the background of the topic. So, what is MDD? Well, major depressive disorder is a mood disorder and the most common psychological disorder in the world. It is characterized by symptoms such as changes in appetite or weight, sleep and or psychomotor activity, decreased energy, and others, according to the DSM-5, for a period of 2 or more weeks. The American Psychological Association attributes a lack of exercise to depression, which is why we picked that exact feature for this um, study. Now that you know what MDD is, let me explain ML. Machine learning is a subset of artificial intelligence and is a model that improves itself through more experience and data. Neural networks are used in machine learning and are based on our human brains. They have these nodes, which are like human neurons. How it works are inputs, like you can see the picture right here. Inputs are passed in, which are then multiplied by weights, which signifies that variable's importance. And if once you add up all those nodes, if it crosses a certain threshold, then one output is fired out. Otherwise, another output is given. There are many neural networks, and the one we created is a novel feed-forward network. It has many parameters, as you can see to the left. And let's continue. So why exactly is this topic important? Let's start with some stats. Johns Hopkins Medicine estimated that 26% of adult Americans suffered from a diagnosable mental disorder in a given year, and the UN stated that depression is the leading cause of disability worldwide and that it affects more than 300 million people a year, or 4.4 of the global population, and 13.3% of the population in the US alone. Clearly, MDD is a global issue, but there are other problems. First is extremely deadly, like I already said, leading cause of disability worldwide. However, it also frequently leads to suicide. Additionally, it is incredibly hard to diagnose without a professional, which there is a shortage of, in fact. In fact, 111 Americans live in a mental health professional shortage area. This means that people can't get the therapy they need and they can't get the antidepressants they need. Now, let me explain our methodology and materials. We used a dataset called the Depression Dataset by Mobius on Kaggle.com. The dataset includes 55 Excel files, one for each participant in the study, and their activity data. You might be wondering, how did they measure every person's activity? Well, they used actigraph watches like the one on the right, which tracks activity through light and movement, which makes it far more accurate than a smartwatch like an Apple Watch. Additionally, there's a scores file that contains demographic info of each participant, like marital status, age, employment, and it also has the following columns for each participant. The patient identifier, like their number, what condition they had, and their MADRS score before and after the study. So MADRS, or Montgomery-Åsberg Depression Rating Scale, is a widely used measure of depressive severity and is commonly used in studies um, before and after the study. This is just a brief literature review we did while we were deciding on the best way to develop our algorithm. We also analyzed 2 more notebooks on Kaggle.com that worked with the same exact data set. So for the process, at first we calculated the mean of all the activity data of each participant, and then we calculated the log of that mean to make the skew of the data less. We call that variable mean log activity, and then we loaded all 55 rows of participant number and mean log activity into 2 Panda data loaders called train loader and test loader. Um, We then used a for loop to run through train loader to train the model, and used another for loop to test the model using the test loader. However, since the variation was so small, the model couldn't differentiate between the control group and the condition group. Thus, we changed the data used in the train and test loader to include just mean activity. In addition, instead of doing the mean activity of their entire time in the study, we just spent for each hour like of every day. Uh, this added variance in the data for our model to utilize and added mode data, but the result was still not great. We altered some of the parameters you saw earlier, like hidden size, learning rate, and these changes helped, but we decided to go a different approach as well. So after all that work, here was our final algorithm. So we used the mean, standard deviation, and zero proportion of activity averaged over each hour in a day, so 1 to 24. And for the trading and testing method, we use k-fold cross-validation, which trains the model on k minus 1 over k parts of the data set and tests the model on 1 over k parts of the data set. We paired this commonly used method with exponential AR, which is an adaptive learning rate, which means that the model adjusts the learning rate or step size in order to keep the model moving forward to a minimum of a loss function. So in layman's term, it just kept the loss to a minimum. So onto the results. Here's how the k-fold training process went over 23 epochs or 23 passes of the training data set through the algorithm. As you can see, our training does very well and stays between 87 to 96% and averages at 91.5%. Moving on, this is how our testing data performed. Our testing accuracies average around 70%, which means there is a definite correlation between activity, data, and machine learning, which allows the model to accurately predict it. On to our conclusion. Through this feed-forward network, we can essentially predict if someone has depression 7 out of 10 times just by them wearing a watch for a couple of weeks. But this is not a perfect model in any way, and there are still some future directions for this sort of research. Of course, using a more advanced algorithm, maybe one that's found in the future, would help to achieve a more definite diagnosis. Secondly, in the future, we could use both activity and MADRS survey data to see the extent of how someone's depression has gone worse. Lastly, combining other known symptoms of depression, such as weight, BMI change, hours slept, and others in one model will help improve the overall diagnosis. Here are the references I used, and thank you so much for listening.
Thank you so much, Shlok. All right, if you have any last questions, go ahead and throw them into the Q&A. But first, so regarding MDD, you mentioned a more advanced algorithm or different data, and as you look at having an impact, what is the most important thing that could be done to help address this and get this out into the world?
Do you mean specifically the this model, or do you mean like MDD in general?
I think the real question was MDD in general.
Okay, so I think the best way to help people with MDD is obviously to get easier methods of diagnosis out, because you can't actually like get medication, like I said, like antidepressants without the use of professional help, and like I said before, there's clearly a shortage, and there needs to be a better way to diagnose people and give them the help they need through therapy and medication.
Got it. Thank you. Another question, how do you factor, I have no idea what this means, I hope you do. How do you factor influences on activity, i.e. employment, school, other factors?
Yeah, so those were just demographic info. I think they just collected it for the purpose of the study to make sure that like it applies to everyone. So like they got children, they got adults, they got people with a job, without a job, they got people of every race, every gender, and that way it made sure that like the data set was applicable to as many people as possible. That way it makes our algorithm generalizable to the general public.
Very cool. And then last but not least, what inspired you to focus on MDD as your topic?
So I've actually been working with major depressive disorder and depression for a long time. I first created an app in the 10th grade, which is called a venting diary. You can find it on the Google Play Store. And it would allow you to like record your emotions and also write diary entries every single day through text and audio. And you could you had passwords and daily notifications, all sorts of things. I developed it myself through Java on Android Studio. And it was after somebody at my school had committed suicide. So that's how it all started.
So personal impact. I have a couple questions we're not going to get to. Reminder, if you have questions, feel free to throw them into Q&A during the presentation, and we'll get to as many as we can, but I apologize to those that we can't get to before we move on. Thank you, Shlok. Really appreciate it. All right, and next we have Krishna.
Just share my screen. Can you see it?
We can see it. Looks great.
Hi everyone, my name is Krishnaveni, and my project is using artificial intelligence in the diagnosis of eating disorders. A bit about me, my name is Krishnaveni. I'm a junior at Basis in Silicon Valley, and I'm very interested in the intersection of biology and computer science. Over 28 million people in the United States suffer from eating disorders, including anorexia nervosa, bulimia nervosa, and binge eating disorders. Eating disorders are usually diagnosed through one of two psychological questionnaires, the ESP and the SCOP. ESP diagnoses eating disorders with a sensitivity of 100% and a specificity of 71%, while SCOP diagnoses eating disorders with a sensitivity of 78% and a specificity of 88%. So the ESP was generally better at ruling out potential diagnoses. Anorexia nervosa is one of three major categories of eating disorders that is characterized by low body weight and limited food intake, and to cause limited food intake as suppression of hunger. People with anorexia often exercise a bit too much, and there are classifications of body mass index that are general for people with anorexia. A body mass index of less than 15 is classified as extreme anorexia. Between 15 and 15.99 is severe anorexia. Between 16 and 16.99 is moderate, and above 17 it's mild. And anorexia is diagnosed more in post-industrialized countries, which means that, which doesn't mean that it's diagnosed less in other countries, but rather that more people seek care for it in post-industrialized countries. Anorexia is of higher risk in female adolescents, and is to rule out all other possibilities before diagnosing it as anorexia. A bunch of physical tests, including hematology, serum chemistry, endocrine hormone levels, ECG, bone mass tests, EEG, and a resting energy expenditure test are all taken before diagnosing anorexia. And anorexia has multiple comorbidities as listed on the screen, but I think an important neuroscience connection is that people who have recovered from anorexia don't have a difference in brain activity when playing a game show and they're losing or winning money. So they have the exact same brain activity when they lose money and the exact same brain activity when they win money. Next, we have bulimia, which is characterized by recurrent episodes of binge eating and compensatory behaviors to prevent weight gain. This is known as a binge purge cycle. People with bulimia have a body mass index between 18.5 kilogram per meter squared and 30 kilogram per meter squared, and comorbidities include menstrual irregularities. And for people who use ipecac syrup, which was previously a poison but is now used to prevent vomiting, there's a risk of cardiac and skeletal myopathy. Finally, we have binge eating disorder, which is characterized by episodes of eating a large amount of food in a short period of time, and thus a lack of control over eating behaviors. 1 to 3 episodes per week is considered as mild, while above 14 episodes per week is considered as extreme. And one major comorbidity for binging disorder is gastroesophageal reflux disease, which is similar to acid reflux, but on a higher level. My proposed approach was an AI framework to detect the presence of eating disorders based on answers to a questionnaire that was based on the Wave 3 in-home interview of the AdHealth database. And I used an XGBoost model with recursive feature elimination, which I'll explain more in later slides, to classify whether or not the patient had anorexia or bulimia or binging disorder. My dataset was the Wave 3 in-home interview of the AdHealth database, and the AdHealth database basically shows 20,000 adolescents who were in grades 7 to 12 between 1994 and 1995, and Wave 3 was the follow-up in the years 2001 and 2002. So the biomarkers that were focused on in the Wave 3 interview was the height, weight, whether or not they had STDs, whether or not they had HIV, and other genetic factors of these adolescents, or of these then adolescents. We also focused on demographics, home family situation, relationships, work situation, and general well-being, like physical and mental. And my analysis circled around the question H3GH8, which was, have you ever been told by a doctor that you have an eating disorder such as anorexia nervosa or bulimia? In choosing which data points to use, I used a technique called RFECD, recursive feature elimination with cross-validation. Basically, this did a thing where it fit a model multiple times and removed the weakest correlations, and then resampled the data set using new testing and training sets multiple times. So the picture on the bottom right of the slide shows cross-validation in a nutshell. Basically, each iteration, it takes on a new testing and training data, and that helps increase the model accuracy. For the AI component of my model, I used the XGBoost, extreme gradient boosting model, and that's basically a tree-based decision-making model with parallel tree boosting. So at the beginning of the model, it provides initially weak predictions, and it then recalculates each tree using gradient descent between the target and predicted values. With all of these in place, my model had a 97.2% accuracy, which is pretty high. And that shows that my model was able to predict anorexia nervosa, bulimia nervosa, and binging disorder accurately in order to prevent potential comorbidities that would have resulted when people develop such eating disorders, and as a result, would be able to provide them with timely care. I think for the next steps for my project, I'm going to submit it as a publication, which was already written and it's submitted to a journal. It's currently undergoing the peer review process and is expected to publish in November. And I'd also like to increase my accuracy and narrow down my model a bit more, because right now I'm using about 50 questions, and I'd like to narrow that down to like 20 or 25 while keeping my accuracy preferably as high as it is. Thank you so much for listening. Do you have any questions? And then these are my references. Thank you.
Nice work. Thank you very much. And go to the questions. All right, so again, I hope you know what they're talking about. Which of the biomarkers or demographics had the largest correlation or predictive ability in the model?
So I focused a lot on the general well-being and the demographic, because I know anorexia and bulimia especially, they have a very high correlation with they have a very high correlation with like the age and the gender of the person. Mostly like female adolescents would be the ones that you would think that have those disorders. So I focused a lot around those two questions, and they tended to have a higher correlation.
Thank you. And then one last question. Is there a way for this model to distinguish between different types of disorders?
So there is a way. I'm still like focusing on making that change. So currently I use binary classification, which is basically like a 0 or 1, whether or not they have an eating disorder. But in the future, I'd like to expand it to like, I guess 0 to 3, whether or not they have anorexia, bulimia, or binge eating disorder.
Great, thank you so much. All right, moving on. Next, we have Claire Loftus.
Okay, I would think I accidentally. Okay. So hi everyone, my name is Claire Loftus and my project is titled Immunotherapies, the next wave of treatments for acute lymphoblastic leukemia. And I chose this type of cancer because it is most common amongst adolescents like myself. So here's the agenda. First, I will go over the background of the cancer. Second, I will review the bone marrow and its structure and function. Third, I will review the 4 following immunotherapies: CAR T therapy, monoclonal antibodies, stem cells transplantation, and checkpoint inhibitor drugs. Fourth, I will then summarize the key takeaways. And fifth, I will take any questions. So acute lymphoblastic leukemia, also known as ALL, is a cancer of the bone marrow. Like all cancers, it begins as a genetic mutation within the DNA. In this case, this is the DNA of hematopoietic stem cells. This genetic mutation causes the stem cells to remain as an immature lymphocyte. These immature lymphocytes, also known as lymphoblasts, will begin to multiply uncontrollably and are then considered cancerous. The cancer will then metastasize by using the bloodstream to reach other areas of the body. So on the left, you have a diagram of the bone marrow, and you can see that within the bone marrow, there are blood stem cells that hold the potential of maturing into red blood cells, white blood cells, and platelets. And then on the right-hand side, you have a hematopoietic stem cell differentiation chart, and you can see that the cancer would occur between the lymphoblast and the lymphocyte stage, hence why it's called an immature lymphocyte. So immunotherapies. Traditionally, ALL has been treated using chemotherapy, but this has proven to have varying success. Immunotherapy refers to treatments that uses a person's immune system to fight cancer or really any disease in general. The immune system is composed of a collection of organs, cells, and tissues that hold the responsibility of protecting against foreign bodies. There are 2 primary advantages of immunotherapies. The first being that they are capable of targeting specific abnormal cells. This is in contrast to chemotherapy, where the chemo treatment not only targets the cancer itself, but also groups of highly mitotic cells, which is why many patients experience hair loss and skin irritation. The second advantage is that immunotherapies are able to utilize the body's own immune system. So the first immunotherapy I will be discussing is CAR T cell therapy. What this therapy does is it uses the body's own T cells to identify and kill the cancerous cells. The first step to doing so is removing the T cells through a process known as leukapheresis. This is done by removing the blood from a patient where the T cells are then separated from the rest of the blood. The remaining blood is put back into the patient, and then the T cells are taken to a lab where they are genetically modified to express chimeric antigen receptors. After this, the T cells are reintroduced back into the body, now able to recognize and kill the cancerous cells. And as you can see in the figure in the bottom right, you have the T cell, the chimeric antigen receptor, and then the final product, a CAR T cell with the chimeric antigen receptors that are capable of binding to the cancer cells. CAR T cell therapy has an overall lasting remission rate of 30 to 40%. Second immunotherapy I will be talking about is monoclonal antibodies. What this therapy does is it forces the T cells and target cells together. So these antibodies are synthetically produced in a lab by B cells that naturally secrete this type of antibody. After this, they are infused back into the body through an IV. And once in the body, these Y-shaped antibodies are capable of binding to 2 proteins at once. And as you can see in the bottom right, you have the cancer cell, the T cell, and the monoclonal antibody forcing the 2 cells together because it is binding to both the proteins. This therapy has a remission rate of up to 80 to 90% and an overall cure rate of 40 to 50%. Third immunotherapy I will be discussing is allogeneic stem cell transplantation. This therapy uses healthy stem cells to replace damaged bone marrow cells. The first step to doing this is finding a stem cell match, which is determined by HLA markers. The patient will then receive a dose of chemotherapy and/or radiation if needed to eradicate the unhealthy bone marrow cells. Following this, the donor stem cells are infused back into the patient to replenish and repopulate the number of healthy bone marrow cells. This type of therapy has a success rate of about 65 to 70% at 5 years, then an increase to 80% if there are no signs of recurrence after 2 years. The fourth and final immunotherapy I will be talking about is checkpoint inhibitor drugs. Their function is to stimulate an immune response, disrupt the signal sent by cancer cells to stop production of T cells, and to block the antigen cell from deactivating T cells. The first step is administering this drug into the patient intravenously. The drug will then proceed to find T cells that are functional, then activate them to proliferate and attack the target cells. This type of therapy has overall cure rates of up to 43% after 1 year. And in this schematic, you can see the interactions with and without checkpoint inhibitor drugs. On the left-hand side, you can see the antigen-presenting cell binding to the T cell, causing it to deactivate, and the tumor cell is able to survive. On the right-hand side, you can see the checkpoint inhibitor drug blocking the antigen-presenting cell from binding with the T cell, allowing it to stay active and kill the tumor cell. So here are the key takeaways of my presentation. Traditional chemotherapies have significant limitations, such as nonspecific targeting, and oftentimes the patient experience higher toxicity levels. However, the immunotherapies I've discussed are more selective in their mechanism of action, decreasing toxicity, and increasing efficacy, particularly in refractory disease. These immunotherapies being CAR T therapy, monoclonal antibodies, stem cell transplantation, and checkpoint inhibitor drugs. These therapies have the potential of becoming a standard line of treatment in the foreseeable future, and their impact extends far beyond the medical field. Ultimately, they are prolonging the life of our loved ones and saving countless lives. Here are some of my sources and acknowledgements. Firstly, I would like to thank my mentor, Carlos, for his instruction and unwavering support. I would also like to thank my parents for allowing me to pursue my interests by participating in this program. And lastly, I would like to thank Polygens for giving me the opportunity to research and share my work. Thank you for attending. I am now open for questions.
Thank you, Claire. Thank you so much. So a couple questions. First, can you compare the remission or overall cure rate of the therapies like monoclonal antibodies and CAR therapy to chemotherapy in a general way or the cancer you studied?
So yeah, in a general way, the overall cure rates are pretty similar to the immunotherapies I've talked about. So this number would be about 40 to 50%. And most of the immunotherapies I talked about were sitting at a similar percentage to that.
Very cool. Thank you. General question. What do you think the chances are that we will cure cancer in your lifetime?
In my lifetime, I could definitely, I don't know, I would say cure cancer is very bold, but I think with the help of these new immunotherapies, I think we can have higher cure rates, which is pretty good as well.
Great. And then last question, what interested you in pursuing this topic?
Well, firstly, I'm interested in pediatric oncology in general. And then I kind of chose this cancer specifically because as I am a teenager, I wanted to learn more about a cancer that affects other teenagers. And then thirdly, we all kind of know about the chemotherapy, radiation, and surgery for cancer, but I kind of wanted to learn more about the new cutting edge sort of therapies, and one of them being immunotherapies.
Got it. And then last question, if the cure rates are similar, why is chemo still a preferred therapy?
I would say this is probably because immunotherapies are kind of just being introduced, and they're also very expensive because they're just being introduced. But I think over time, when they are more widely used, the expense will decrease, and then they could become a secondary treatment to treatments like chemo. And then also, yeah, like I said, at the moment, chemotherapy is the dominant treatment for this type of cancer, but immunotherapies are starting to be used. So if the cure rate for chemotherapy is only 40-50%, the remaining 50% is used for, or immunotherapies are used to treat.
Okay, thank you so much.
Thank you.
All right, and then rounding us out today, we have Marco.
Hi everyone, sorry. Okay, can you see?
We can see it just great.
Perfect. So, hi, my name is Marco, and I am a senior student at St. Louis School in Milan, in Italy. And today I am going to bring you through a sector-by-sector analysis of the UK furlough scheme. Specifically, my research question is, how effective was the furlough scheme in achieving the short-term recovery in the food and accommodation sector compared to the arts, entertainment, and recreation sector? As each paper has, it's necessary to have a very strong thesis to support your argument and give enough context to the reader. My thesis and my paper is generally comparing the sector, arts, entertainment, and accommodation, and food sector during the pandemic, and search for any factors that dictated the short-term recovery. Specifically, I find two major factors, which were the sensitivity to COVID-19 restrictions and the presence of other types of government intervention. Before examining the two sectors specifically, I am going to give you some background context about the furlough scheme. So the furlough scheme was brought in by the Chancellor Rishi Sunak in the spring of 2020, and the aim of the scheme was to enable employers to keep staff in job while businesses were shut down due to an outbreak. The scheme essentially provided grants to employers so they could retain and continue to pay staff during coronavirus-related lockdowns by furloughing employers up to 80% of their wages. This was, however, capped down at $2,500 a month. Basically, the furlough scheme was a wage subsidy to firms during the pandemic, and any UK organization was actually entitled to this scheme. However, if you started your job after the 19th of March of 2020, you weren't entitled to make use of this. Now we can specifically analyze the food and accommodation sector. However, it's crucial to understand what is actually the food and accommodation sector. So all the establishments that offer lodging, prepare meals, snacks, and beverages for immediate consumption make up this first examined sector. As we can see from the graph on the right, the peak in this sector occurred in May with 1.6 million jobs furloughed. As time passed, the amount of jobs furloughed decreased as we entered the summer period, where COVID restrictions such as lockdowns, use of masks, and social distances started to decrease. As this occurred, individuals tried to restart their ordinary life, traveling more with families and visiting local restaurants to have a great time with their family, thus increasing the revenue of all this sector. Therefore, by increasing the revenue, they were now able to cover most of their expenses. This is one of the major reasons why the amount of jobs furloughs decreased substantially. Another reason for this was the additional help from the government with the Eat Out to Help Out scheme, which occurred during the summer of 2020, so from July until September. The Eat Out to Help Out scheme consisted in government paying most of the consumers' bills, encouraging them to consume goods provided by their restaurants, by local restaurants. As we can see, then unfortunately, once the second scheme finished and people started to return to their ordinary life during October and entering the winter period, the amount of jobs furloughed spiked again. This was because of one major reason, which was a lockdown, which negatively affected the food and accommodation sectors. This is the reason why the amount of jobs furloughed increased. However, as time passed and the threat of COVID started to decrease, the amount of jobs furloughed as time passed, nearly went to zero. Even though the furlough scheme was one of the biggest users, even though the food and accommodation sector, was one of the biggest users of the furlough scheme, it presented an astonishing decrease in the amount of jobs. Specifically, 90,000 workers lost their jobs during this period, which is a big amount, but not as big compared to the whole labor force, which was 2.4 million. Now we can specifically analyze the second sector of today's presentation, which is the arts, entertainment, and recreation sector. Also here, it's crucial to understand what is it, and it's all numerous businesses that run facilities or offer services to suit the diverse cultural, entertainment, and recreational interests of all the clients. In contrast to the first sector examined, so the accommodation and food sector, this second sector had a peak of 0.4 million jobs in May, which at first sight might seem a little amount. However, if we examine the labor force, this amount was actually very high because the labor force of the arts, entertainment, and recreation sector was of 734,000 people. Therefore, it's a really high amount. Some economists argue that this second sector did not adapt well to COVID restriction. This is because the shift to online shows and online forms of entertainment weren't as effective as they were in person, attracting fewer customers to the businesses. And in addition, this sector was also helped much less compared to the first sector, as they didn't receive any additional scheme, direct scheme that helped to generate higher profit. This is one of the reasons why the amount of jobs furloughed remained fairly constant, except a little decrease during the summer. Now that we have a clear understanding of the two sectors examined, it's necessary to zoom out and understand some advantages and disadvantages of the furlough scheme. As many of us can clearly understand, one main advantage of the furlough scheme was that it prevented a return to mass unemployment. The jobless rate actually increased to 6%. However, imagine what it would have happened if this scheme wasn't enacted by the UK government. This jobless rate would have been much, much higher. In addition, it also maintained commercial viability of many thousands of small businesses because the government was able to cover their expenses, helping them and avoiding them to close their activity. In addition, it also helped workers receive the most of their wages, helping them provide for their families and for themselves. Unfortunately, as we said before, this scheme also has some disadvantages. And one major one that each one of you, I think, is thinking is really high fiscal cost, because the amount of jobs furloughed throughout the whole scheme was of 11.7 million jobs, which had a really, really high cost on the UK government, more precisely of $70 billion, which was an astonishing amount, which increased substantially the UK government's sustainable debt. In addition, there is also another disadvantage, as it's crucial to understand, which is a risk of resource misallocation, because some economists argue that the furlough scheme preserves at a very high cost jobs that theoretically are not coming back post-pandemic, preventing workers from being reallocated to growing sectors, which would have been more beneficial to the UK economy. These are my references, and thank you really much for listening to my presentation, and I would be really happy to answer all of your questions.
Thank you so much. Quick question to kick us off. Can you tell how many workers changed the type of work they did throughout the course of the pandemic?
Unfortunately, I haven't researched exactly, but many workers, as I've said in the third slide, in the food and accommodation sector, 90,000 workers completely lost their job, which wasn't still a big amount because of the 2.4 million in the labor force. However, I know that around from 5 to 10% from 2 to 3% remained unemployed, while the rest had successfully shifted to another work, which was maybe more beneficial to the economy, but I haven't specifically researched that.
Okay. Couple more questions. Have there been any attempts to determine what the unemployment rate would have risen to had this scheme not been enacted?
So there hasn't been any type of additional research, also because the furlough scheme is a really close event that happened and just finished. So there is a limited amount of resources and data that we can analyze. But I've done my best to understand what it would have been possible this jobless rate to arrive. And if we examine past events such as the 2008 crisis, I also talked to my mentor, which was Sunny Wang, and we discussed that for us this jobless rate would have been much higher because businesses were basically forced, some businesses were basically forced to shut down, and also very big businesses were shut down, meaning that all the workers inside them had to return home with no job. And this led also to a Great Depression.
Okay. And then the last question, given what is known now, what changes would have made this scheme more impactful or more affordable?
So I think that in my opinion, I believe that to make this scheme more effective, we could have the UK government could have targeted specific sectors that would have been more beneficial in the future to the UK economy. For example, sectors that included artificial intelligence or technology, instead of, for example, this arts and entertainment sector, which is slowly going away.
Got it. Thank you very much.
Thank you.
And that concludes the session. I'd like to say thank you to all of our student presenters, and thank you to you, our audience members, for sharing your morning and your great questions with these amazing scholars. We're only getting started. So when we close here, I hope you'll enjoy some of the other presentations and the rest of the symposium, and that you have a good morning or evening, depending on which time zone you're calling in from. Thank you, everyone.